Hey, so what we're going to do today is build a Zerg bot using PySC2 2.0. This is just being released, probably in the last day or two. It has a lot of cool new features, so if you've seen my previous tutorials, this is probably a good tutorial you can start again. This time I'm going to do it with Zerg instead of Terran, just to change it up a little bit. We're going to introduce a few new concepts. But generally things are similar, but some stuff is sort of changed to make things easier, and there's a lot of access to more information that should make it a lot easier to build a bot. So the first thing I've got open here is my code window. The first thing we want to do is from PySC2 import to PySC2 dot, I think it's .agent. Let's look here. .agents. Import base agent, and then we'll make our class Zerg agent, which extends from base agent. Okay, and then probably the most obvious part of an agent is going to be the steps. So each time, the game basically is a series of steps, and so you have the ability to take an action at any step. The default for PySC2 is that you will choose an action every 8 steps. We can actually do an action every 16 steps. That's probably around about 150 APM. I think I'll probably do that for this because there's not a whole lot to it. It's fairly straightforward, fairly simple sort of stuff. So I think that's what I'll do for this one. As you get more complex, you'll find that you probably want to start using some of the higher APM. So you want to take an action on fewer steps. Once you go below an action every 8 steps, you're probably getting into the realm of exceeding what a human could do. So if you want your bot to be more human realistic, you probably want to not go any lower than about 1 action every 8 steps. But if you don't really care about that, then you can drop it down to 1. So, but it just depends on what works for you. Also, you may find that if you have a machine learning algorithm, that the algorithm may learn better if you have take an action every 16 steps instead of 8. It sort of depends on what you're doing. So here's the base agent. This really just gives you a bit of utility to take action in the game, and the most important part of this is the step method. The argument you get here, the obs, is the observation, the game observation. Inside that observation is going to be information about the world, really. So there's a series of screen features, which is essentially the screen may be 84 by 84 pixels, and each layer might include the terrain. So it might be the height of the terrain, so taller or lower, or ramps, those kinds of things. It's going to include units, so buildings or your units or enemy units, neutral units, that kind of thing, and also visibility. So whether you've seen it, whether you haven't seen it, and whether you currently can see it. There are some other things, like I think you can see energy for Protoss, you can see creep for Zerg. So there's a few other little bits and pieces in there. We're not really going to get into those too much. We may use a few bits and pieces, but we're not really going to get into that too much, and you can sort of explore that yourself. So everything you get from your bot can find out information about the world around it. It's going to come from this obs parameter that's passed in here. The first thing we want to do is call the parent agent. I'll call it Zerg agent, because it has a few sort of important steps, pre-step things that it needs to do, and then the simplest agent will do nothing. So every step it'll do nothing. So we want to return actions.functions.no_op. Okay, so if you've looked at previous tutorials, this is probably the biggest change that you'll notice straight off the bat. Actions.functions.no_op. It used to be a lot more complicated than that to perform an action. Let me just have a quick look and see if I can find one of my old tutorials. Maybe a basic agent somewhere here. Okay, so when we used to perform actions, you used to do return actions.function call. You would pass it in a function ID and then a series of parameters. So you'll find that it's slightly different in this case. You can actually, instead of passing the function ID, you can actually call the function directly there, and then you can pass the parameters in here. So it's a little bit more self-explanatory and makes it a little bit easier to read. So that's your basic agent, and you can actually run this from the command line, but that's what I did in the first tutorial. In this tutorial, what I'm going to do is show you how to run it from within the code itself, and that's kind of pretty handy because there's going to be a few settings that you're going to want to set, and it can get pretty tedious setting those on the command line. Instead, if we set it in here, we have full control over it, and it makes it a lot easier just to run this script. And if you're using an editor like I am, then it's going to be a lot more straightforward. So let's have a look here. That's just my cat playing at the door, don't mind her. So that's our class there. I'm just going to set up the main method here, or the main function. And for this example, we're going to use the Gristle Reef map. I'm doing this because the Simple 64 map that I did in the original tutorial, it's nice and simple and all that, but it's a lot more fun to play on a full-size map and kind of get a feel for how much is going to be involved in building a full-size bot. So put this in a try-catch loop so that we can catch when someone interrupts with the keyboard. None. Okay. And then inside here is where things get a little interesting. So we'll create basically an infinite loop. When we don't want to be in this loop, you can press the keyboard to abort basically. So with sc2env.sc2env. So first thing we're going to have to do is bring in the sc2 environment. There's some pretty handy stuff that comes out of the box with PySC2, so you won't have to do too much coding in that regard. It sort of spools up the environment and does all the work for you. You just have to tell it what you want. So from there we get the environment. That's great. Now the next thing we want to do is say which map we want to use, which map name is map. We could put a Gristle Reef here, but I have some code that I sort of have evolved from this, which I can use to generate a random map, or you know, one of the ladder maps, or a fixed list of maps, anything like that. So this sort of gives you the ability to play with that variable up here before you get into the for loop. You can even do it a little bit further in here and generate a random map, but that's sort of up to you. Now the next step is we want to define the players in the game. This is slightly different to the original PySC2 or 1.x, where you would specify the agent, your agent, and then what the bot would be. You can actually specify two bots that play against each other. So you can have two agents and they can play against each other. I've got an agent that is a random agent that plays against itself, and whichever race it gets, it kind of learns how to play as that race. So that's kind of cool. So we'll define the players as sc2env.agent, sc2env.race. Now, in this case, what we're going to do is use Zerg, and let me just find I need to find my other code for the other part of this agent here. This one of these ones here. This will be a little bit better. Just have to steal a little bit of code out of here. Nope, it's not going to be in this one. It's going to be one of these other ones. Okay, here we go. Let's bring this out over here so I can read it. There we go. Okay. So that defines the first player is going to be an agent, or our agent, and the race is going to be Zerg. And then the second player is going to be a bot. The race, let's say random. And then I'm going to set the difficulty to very easy. Cool, that should be pretty much it from there, I believe. Yep. All right. So that's a lot more straightforward than passing in all these arguments on the command line, I think. Yeah, definitely I feel like it's a lot more straightforward. Okay, so we've got the players. Now here's the next part that's kind of interesting. We've got an agent interface format. So this really allows you to say that each agent could actually have a different set of parameters in the way that it views the world. So by default, the screen is 84 by 84 pixels and the minimap is 64 by 64 pixels. If you wanted to change that for one agent to be higher resolution and another agent to be lower resolution, you can do that here in these agent interface formats. So in this case, we're just going to specify for our one bot features agent interface format. Okay, and that reminds me that we need to import features. So from PySC2.lib import features, which is cool. That gives us our agent interface format. And inside the agent interface format, we can specify some of the things that we used to specify on the command line in the original tutorial. So feature dimensions is features.dimensions. Now this is where we can specify the screen and minimap size. So I'm just going to do them manually here. So screen equals 84 and minimap equals 64. Now we may be able to put these on the same line. We can. Sweet. Okay. And what else have we got here? Here's one of the cool things about the PySC2 2.0, and it just happens to be my code. It's feature units. So we can turn on feature units. What is feature units? Well, essentially, if you've worked with PySC2 1, you had those screen layers and the minimap layers that I talked about before. There's another sort of way to work with the API, the StarCraft 2 API, and that's using the raw API. And I've sort of modified that and brought that raw information, which potentially exposes information that's not always visible to a human, and it sort of brings that information through. I've filtered that into what a human would most likely be able to see and kind of work with. So there's some cool stuff. If you worked with the original tutorial, some of the things you had to do, you may get the location of a particular unit, but only by which pixels it consumes on the screen. So in order to select that unit, you had to click on one of those pixels. And you could determine approximately the center of that unit by getting the mean of the X and the Y coordinates of all those pixels and that kind of stuff. With feature units, it'll tell you the exact center of that item, the radius of that item, and then some other information about the item. For example, it will tell you if it's a command center or a base of some sort, what the ideal worker count is and what the current worker count is. And that sort of information wasn't available in the screen and minimap layers and the feature layers. So it gives you a little bit more information. It's probably not true to the, observing the pixels and kind of acting, but I find it's a lot easier to work with, and gives you a little bit more information that just isn't visible elsewhere. That's kind of crucial to operating. So that's the agent interface format. Okay, just tab those in a little bit. And then the step multiplier, step mul. So this is what I was talking about before, where you're going to take an action once every 16 steps in this case. The default would be 8. And then game steps per episode is 0. This is actually just saying infinity, yeah, I believe in the first one, if I just double check, I believe in the first one it was limited to a certain number of steps for the simplicity format. So I believe it was about half an hour on a normal speed and about 22 minutes or so on the faster speed. So this removes that limit, stops the game from just terminating at any moment. There is one other parameter you could pass in, which is visualize, and you could set this to true. I'm going to set it to false, but if you enable the visualize, it will present you with a full version of the game and all the layers that the bot has access to, and that can really help you to diagnose or to understand what's going on. I thoroughly recommend that you do that if you're just starting out and you're trying to sort of get a feel for what this whole thing is all about. So there we go. Maybe that's all the parameters that we need. I've probably got something wrong here, but we'll find out what that is when we get there. Okay. Now the first thing we're going to do is, once we've got that set up, inside here is agent.setup. I just realized I am missing my agent. Okay, let me just do this up here. So we will create the agent up here as well. Agent equals Zerg agent. There we go. That's our agent there, as you can see. Now we set up our agent with the env.observationSpec. Oops. And the env.actionSpec. Okay, so that just gives us some basic information to get started. Time steps equals env.reset and agent.reset. This is all just setup stuff. You don't really have to know too much about how this sort of works. Now we can create another infinite loop. Step actions equals agents.step time steps 0. And then if time steps 0.last, so if it's the last step, we want to break. So this quits out of our infinite loop if it's the last step of the whole game. And then for the next step in our loop, we will step through our actions. Okay, let's see if we can give this a test run, and it may or may not work. We'll see. So we'll run this here. I'm sure something will break. I have a habit of doing that. Okay, nothing's working right now. It's not running because we've got the last little bit of code. I told you something would break. Okay, last little bit of code here. If main is equal to main. Oops. we're just missing one more library, I believe. So import. If you're wondering where I got all this from, there's the agent.py bin PySC2.bin.agent.py. I kind of took all the code that's in there for dealing with the command line arguments and all that sort of stuff, potentially handling multiple agents, and just fed it into this one. Okay, now let's see if this will run. Okay, the window's up there. Oh, so there's our visualize, and okay, a few things have crashed, but that's cool. Okay, I've set the visualize to false, and we didn't import actions, so we just want to import actions here. And we'll run that again just to prove that it does actually work. It's always going to be something that's going to crash. Okay. This should be actions, I believe. Let me just double check my code on this one. Actions, that's right. Just need to fix this to actions.function.noop. Fingers crossed this is the last one we have to fix. Cool, there we go. So as you can see, it does a whole lot of nothing, but that's step one. So that's really just the basic environment setup and the basic agent setup. That's pretty much all we need. I'll leave that running in the background. It'll probably die in a minute, so it doesn't really matter. So back to the bot here. So what are the steps we need as Zerg? So first of all, we've got lava that we need to be able to select. We need to be able to turn that lava into drones. We need to turn the drones into spawning pools, or a spawning pool, so that we can then turn the lava into Zerglings that are going to run across the map. So first thing we need to do, try and select the lava. So let's see if we can, we'll have a look at the feature units. This is going to be the good part. Might just stop this game that's running in the background now. Okay. So, trying to remember all the pieces of code that we need to pull this information out. Okay. I know what we can do. Okay. So lava units equals unit for unit in obt.observation.feature units. I'll probably get this wrong. If unit.unit type is equal to, now there's another thing that yours truly added to PySC2, which is the units list. So the units list, which is this file here, gives you a nice name for every single unit in the game, as long as it's been updated. And so it makes it a lot easier than the old ID system that we had in PySC2.1. So in this case, we can go down to Zerg, and we can see that we've got lava here somewhere. There it is. It's usually the name that you would think it would be. So we import that units module here, and then if it's units.zerg.lava. So what have we done here? So obs.observation, if I spell it right, obs.observation.featureUnits contains all of the feature units on the screen, all the units on the screen, and a bunch of information about them. If we have a look quickly here, not this one here. If we have a look quickly here, you can see some of the information that we have: unit type, alliance, health, shield, energy, all this sort of stuff, which is quite cool. The X and Y coordinates, whether or not it's selected, mineral contents, which is good for mineral patches, Vespene, which is good for Vespene gas geysers and any buildings that are on it. The assigned harvesters, which is good for your bases, and your ideal harvesters, which is kind of cool. So there's quite a bit of information there that you may not get through any other source. So we loop through all those units, and then if the unit type is a lava, then we will return it. So we end up with a list of lava units essentially that come back. So if length of lava units is greater than 0, so if we have any lava units, then what do we want to do? We want to select those lava units. So return, actually we might do lava unit equals, so we're going to need a random now, so import random equals random.choice lava units, and then we want to return actions.functions dot, and now this is where we can go into this actions file, which is also part of PySC2, and what we want to do is do a select point, which is going to be on the screen. So we do actions.function.select point, and we're going to do now, I believe we have to say when we want to select that point. Actually, no, it's a select all. So we want to do select all type, which is cool. So with lava, you could select all the lava by doing a control click as a human. We can do select all type as part of this API, which does the same thing, which means we can select all the lava in one go. So select all type, and then we want to pass in the lava unit X and lava unit Y with a comma in there. Okay, cool. Now we'll run that and see if that works. Nope, got something wrong. Okay, lava unit, that's because I can't spell. There it is. That's why it wasn't auto hinting. Give it another run. Cool, so you can see there that the lava is selected, little green circles about everything. So that's step one. Okay, so we've got our lava units, we're selecting those lava units. And we want to be able to build something out of it. So what do we want to do? We want to determine if the units actually are selected. So we can get that from the observation as well. So this is from the features here. We should be able to get that using the, not the screen features, not the minimap features. It'll be in here a little bit further down. Okay, so should be a single select and a multi-select. There you go, single select, multi-select. Now, let me see. So if obs.observation.single select, so I might do the length on this one, len is greater than 0, and obs.observation.single select. I have to write this on a few lines. 0.unit type is equal to, copy this one out of here. So what are we doing here? If you've got a single selection, the user interface has a different appearance to when you've got multiple items selected. In this case, if we've got one item selected and the item's unit type, we're selecting the first item here, the unit type is lava, or actually we might have to wrap these in two, or, and I've got to figure out why my parentheses are all over the shop. Okay, we need another one on the end here. That is there. Okay. Or len obs.observation multi-select is greater than 0. Put parentheses on this. And obs.observation.multi-select. Once again, we're just going to get the first item in the multi-select. We're going to assume, for the purpose of this tutorial, that that we're always going to have just one unit type selected at any one point in time. So now we've determined that we've probably got the lava selected. So if we've selected the lava, what do we want to do? We want to turn that lava into a spawning pool. So return action.functions, and then so the action for a spawning pool is you'll put spawning pool on the screen, and we want to do you know what we want to do? We want to convert it into a drone. So actually what we want to do is, I believe it's called train drone. Let's have a look here. Train drone quick. Alright. That's more like it. So before we can build a spawning pool, we need to convert the lava into a drone. So let's see if this works. Once again, my ability to type has gotten the better of me, and there's an obfuscation in here. Probably don't want that. Let's go with an observation. Hey, Prince Athos, how you doing? All right, you'll get used to this. I make a lot of mistakes. All right, actions, and it can be a little bit tedious when you write a bunch of code and you have to run a game and it takes a while to spool up. It can be a little bit tedious, but you will get better at it. And over time, you'll add a few utilities that make it a little bit easier. I've got a few utilities that I use that kind of simplify these things so you make less mistakes. But I still can't type. Been doing this for 20 years and I still can't type. Okay, wrong number of arguments. we want to say train it now. So some of these quick actions don't need you don't need to say tell it when you want to do it. Apparently with this one you do need to tell it. So I believe you can say now or queued, which is good because in the old PySC2 1 you had to pass in like a 0 or a 1, which was a little bit annoying. There we go. So we did start training one, but it's not available. So what do we do here? We go if actions.functions.train drone. I'll get there. Quick.id is in obs.observation.available actions. I'll drop this down to a couple of lines. There we go. So it'll only train the drone if it can do it. So it looked like in that case it had enough minerals to train the drone, but then the second time it tried to train the drone again and it couldn't do it. So we'll just run that again just to make sure. And what should happen is the lava turns into drones and then magical things happen. Hey Keanu, yeah, it's I thought I'd do something different. Zergbots are kind of I've been sort of playing with Zerg and Protoss a little bit lately, so it's I think Zerg is an interesting idea for a bot because it's you don't have to worry about walling up, and but then of course on the other side of building a Zerg bot is you've got to spread creep and do things like that, which is very difficult to do. Okay, so it looks like it built at least one drone from what I could see, or 2 drones maybe. So that's cool. Let's go with this. So train to drone, and now what we might do is abstract a method out here for finding out if a unit is selected. So def unit type is selected. Unit type. I'll just double check that this logic is all good. I've got some logic that I can copy from one of my libraries just to make sure. Sometimes it's not always. Yeah. I'll use this one. It's basically the same code as what I had. It's just more thoroughly tested. So observation simple select, passing the observation, and just say is equal to unit type, and multi-select. Make sure it's equal to unit type. So this little method here just wraps up the code that we had here. It makes it a little bit easier to you know, check if a unit's selected without having to write all this code over and over again. So if self.unit type in the end is selected. Cool. I think that should all work. Selected. Sweet, that makes more sense. Cool, so if we've got lava selected, then we can train a drone, but what do we want to do? We want to see, well, maybe we could select a drone and build a spawning pool straight up. So we'll do the same thing here, but we'll do it with drone units. Drone units, Zerg.drone. Or obviously you could do the same thing here where you could abstract this out to a method. So we might even do that now. Def get units by type. and we'll pass in the observation and the unit type, and then we can return any unit that matches that unit type. Unit type. Sweet. So drone units equals self.get units by type obs, and then drone, and then self.get units by type, and lava. Cool. So that's looking a lot simpler and sort of neater. Now, got the drone units. If then drone units is greater than 0, so if there are any drone units, then what do we want to do? We want to build a spawning pool. And this is kind of a tricky bit because you have to choose a location for the spawning pool. So let's first check and make sure that we can actually perform this action. Action.actions.functions. I had it in there before, but it's called build spawning pool. I always find it easier just to copy and paste these, but you can do what you need to do. So just build spawning pool screen, we'll say now, and then we're going to have to supply some X and Y coordinates. So for this, actually, let's avoid this. Let's just check if it's in there. Let's do available actions first. And obs.observation.available actions. Okay. So what we want to do, we know that we've said down here that the screen is 84 by 84 because that's kind of the default. So we want to say x equals random.rand int 0, 63. So that'll give us a number between 0 and 63, and y is the same. And then we want to return actions.functions.build spawning pool screen now, and then x, y. Okay, so one of the things that you can do here is take this little thing and create a method called, I like to call it can do. Can do, which gives you the obs and the action, and then return. I think we may even be able to do some on the line. Just a little bit neater. So self.canDo, and that sort of allows us to put that whole thing on one line, nice and easy. Self.actions.canDo. Cool. So, you know, just condensing things down and making it a bit simpler. So we hopefully, you know what we've got to do? We've got to select the units first. So we want to do the same thing here. Let's just cancel that for a minute. So drone unit, we choose, once again, we choose a random drone unit. We feed in X and Y, and then since we've already written the code, if we've got a drone selected, and if we can build a spawning pool, then do that. So I've kind of skipped a few steps there, but essentially select the drone if you can. If you've got the drone selected, then build the spawning pool. And I might just drop this logic up above. So once we've looped through and we've selected a drone, the first thing it's going to do is try and build a spawning pool. Otherwise, it's just going to sit there selecting drones forever. So that should be all good. It should be all good. Okay, let's see if it builds a spawning pool, or if I've typed something incorrectly again. typed something incorrectly again by the looks. Can do, I'm missing the action. I've got to pass in the observation to this can do thing, don't I? Obs here and obs here. Okay, here it goes. There we go, it's building a spawning pool. That's pretty cool. The problem is it's going to consume all of our drones and just build endless spawning pools. So that's going to be a bad thing. So what do we want to do? Okay, so we want to get the spawning pool count. So spawning pool units equals self.get units by type. Units.zerg.spawning pool, and if len spawning pool units is equal to 0, then so if we don't have any spawning pools, then we will try and grab a drone and build a spawning pool. So these two things here, select the drone and build the spawning pool. Okay, that should be good there. That should build only one spawning pool. Now, it should get to here if we have a spawning pool. We do want to select the larva at this point. But we don't want to train a drone. What we want to do is train a Zergling. And that should be good. So what's it going to do? It's going to build a single spawning pool, and then it's going to train a Zergling. Let's see if this works. Here we go. Every time I type something incorrectly. Okay. Well, I need to pass in the observation here, and I need to pass in the observation here. So I think that should be everything. Just double check. Explosions. Okay, what do I type wrong here? We'll get there eventually. Okay, and go again. Spawning pool. Zerglings. Yes. So many Zerglings. Alright, so what do we want to do with those Zerglings? We've got to send them across the map. But before we can send them across the map, we need to probably find out where we are on the map. And this is something that was part of the original tutorial. So let's see here. So I'm just getting my bearings. It's slowing down my computer a lot when it renders, so I'll have to close that one. Alright. Just going to double check my information here. Yes, okay. So this is a little bit tricky, but this is part of the same code that I had in the first tutorial. And we're going to do this on the first step of the game. So if, what's it called? Let me just double check. If obs.first, I thought it was there, but I wasn't sure if it was at that level. Then we want to get the, oops, then we want to get the player x and player, we want to call this coords, see if that works, equals obs.observation, yep, that's right, dot feature minimap. So this is one of the main differences with the PySC2 1. It just used to be called minimap, now it's called feature minimap. And that's because there's the RGB layer and that sort of stuff now, so everything's sort of trying to be a little bit more specific. Dot player relative is equal to features dot player relative dot self dot non-zero. We'll do player x and player y. Player x, player y. Go. And then what I want to do here is we need to make an init method, and in the init method we have to call the parent class as well. So super Zerg agent, not that one, Zerg agent, down there, self init and self dot base location equals 1. And then in here, actually what I might do is set the attack coordinates, and these are going to be predefined attack coordinates, but that's fine. That's just, this is for the purpose of the tutorial. How you make your bot find the enemy and attack that location is up to you. You can hard code it into so it knows on this map, here's all the locations and here's where you can attack. You can add machine learning, you can add some scripting to search around, do those sorts of things. In this case here, I'm just going to make it attack across to the other corner. The main thing is that we need to find out which corner it's in first. So xmin equals player x.min and ymin equals player y.min. So what this do, it just takes the x and y coordinates. So out of this piece of code here, what does this do? You have a minimap which is 64 by 64. It has these layers, and player relative is one of the layers. We're saying on that layer, let's get all the pixels that have a player relative of self, and then getting the non-zero ones. This gives us the coordinates, essentially the x and y coordinates. I've just realized y comes before x because in this case it's drawn from the top down, and then it works its way across those. So you get the y coordinates, and then within those y coordinates are the x coordinates. Then you get the average of those coordinates, so you get the average of the x and the average of the y, and that should give you the center of your units on the minimap, essentially. When you first start, those coordinates are accurate enough that you should know you're on the top left or you're in the bottom right for a map like this. There are obviously some more advanced methods you might have to use if there are multiple spawning locations, or if the spawning locations aren't in the corner. You may have to have some sort of a range to search in. For this map, we can say if xmin is less than or equal to, say, 33, and ymin is less than or equal to 33, because it's, 31, because this is 64 by 64. So half of 64 with a 0 base is 31. Then self dot attack coordinates. Now I'm going to have to look up these coordinates. I do have a little bit of cheaty code that I use for some of my bots, if I can find them in here somewhere. So the top left coordinate is 1216. Oh, so the bottom right coordinate will be 4747. I'm pretty sure that's how it works. So if we're in the top left, which means that the x and y are less than or equal to 31, which is for you the top left, then attack the bottom right. Otherwise, we're going to attack, and I believe it was 12 and 16. I'll double check those. 12, 16. Cool. So it's just going to attack the coordinate bottom right there. Good. Morning pool, drone units, Zerg. So now Zergling units equals self.get units by type, units.zerg.zergling. What are we doing here? What we want to do is, we've got Zerglings, we're going to send them out across the map. We're not going to pay attention to building them up or do anything like that for right now. You could do it quite easily, and maybe I'll elaborate on this, but for right now we're just going to send it across the map. So if we have some Zergling units, which is, we can check the length, not by that, Zergling units is greater than 0, and if they're selected, then if self.can obs actions.functions.attack minimap, I believe. Let me have a look. Better look this one up before I spell it incorrectly. Attack minimap. No, attack a minimap. And then I say now, and then we give it the coordinates. So self.attack coordinates. See if this wraps. Nope. Okay. If we can, I've done the same thing again, where I'm checking. I'm trying to give it the command before I check whether I can do it. So, and then return self.actions.functions.attack minimap. Done and done. Okay. Don't need that. Okay, so if we're going to attack the minimap, let's attack the attack coordinates bottom right or top left. Now, if we don't have the Zerglings selected, what we need to do is try and select them. But instead of having to select a specific Zergling, we can select the entire army. So if self.can obs. Now there's another action called select all army, I believe. Nope, let me have a quick look down in this list. It's one of those. Could just be called select army. There it is. It's just called select army. Okay. So if we can select the whole army, which you pretty much can. Don't need to return myself. I've just realised there, and that will allow me to write this. That's better. So if actions.functions.selectarmy.id return actions.functions.selectArmy. I think you have to do select because it's a selection type. I think you can deselect or reselect. I'll just have to double check that one, but see what the actions say here. It just says select army. Maybe it will just select them all. Cool, so select army and attack the bottom right. Let's see if that works. Go spawning pool, Zerglings, attack. There you go. So it should wait until those units are dead, and then it's going to spawn some more Zerglings, and then it's going to keep sending them across the map and waiting until those units are dead, and so on and so on, and just keep firing them across the map, because why not? So why don't we just get a little bit more interesting with this? Well, first of all, we probably want to add some overlords, right? Because we've kind of got a limit of 14 units. So, and 12 of those are going to be taken by our drones. So, let's see. We can actually get the current supply. It'll be in here somewhere. Player, food used and food cap. Yep, so we can get, let's just have a look in here. Now, got our Zergling units, we can select them, we've got our spawning pool units. If we've got a spawning pool, we can select the lava, and then it's going to train the Zerglings. But what do we want to do? If obs.observation.player, what we might do is free supply equals observation.player.food cap minus obs.observation.player.food used. Now this will tell us how much free supply we've got, really. And if free supply is 0, then we want to try and create an overlord instead. And that's pretty much as easy as changing the word Zergling to the word overlord. Yeah. So as soon as it hits 0 supply, it's going to train an overlord. And then what we might do at the top here is we've got the Zergling unit, but why don't we wait until we've got 10? So we can do greater than or equal to 10 Zergling units. So once it hits 10 Zerglings, it's going to send them across the map. And then it's going to queue up 10 more Zerglings and send them across the map. So let's see how this works. Cool, spawning pool. Zerglings, overlords. Yeah, out go 10 Zerglings. Out go 10 more Zerglings. More Zerglings. With that, we even got to surrender early. Here it goes. So maybe we see if it clumps up. It looks like it might get a few more Zerglings in there and it might clump up and defeat. Yes. Winner! There you go. You just built a Zergling that beats the very easy AI on the Abyssal Reef map without really having to work too hard. So that's a basic Zerg agent built on PySC2 2.0. As you can see, the interface is a lot cleaner. The dot notation I find a lot easier to use. The actions you can call and the parameters are easy to pass in and a lot clearer. You've got the new feature unit stuff, which allows you to select the units, get their locations and select them more easily, count them, do all that sort of stuff a lot more easily. So, you know, it's really not that hard to get started with PySC2 2.0. So I recommend you give it a shot. Thanks for watching. That's going to be it for tonight, and I'll see you another time. See ya.